Hello everyone, myself Sushant Aldar, and today I am going to present my PPT on the topic of propositional logic and first order logic. So let's get started. So why is this so important? Well, before an AI can think, learn, or reason, it needs a formal language to understand and represent the world. These logics are that language. Over the next 10 minutes, we are going to explore that what they are, how they work, and why one is good, but the other is essential for building truly smart systems. Let's see Introduction to Logic. So let's take a look at the big picture. Everything starts with logic, which is the core study of reasoning. In artificial intelligence, we use logic to build systems that can make valid inferences, meaning to draw correct conclusions from data. As you can see from this chart, this branches into two main paths. Well, we will discuss today. First, propositional logic, which deals with simple basic statements, and second, first order logic, which is much more advanced and can handle complex relationships. We will start with the simple one first. What is propositional logic? So, what exactly is propositional logic? It's a branch of logic that deals with statements called propositions. A proposition is any statement that can be definitively true or false, but it can't be both. For example, it is raining is a proposition. Either it is raining or it is not. That is 2 plus 2 is equal to 4 is also a proposition, a true one. But look at the last example. Open the door. This is not a proposition. Why? Because it is command. It can't be true or false. Propositional logic can only handle those simple true and false facts. Let's see propositional logic components and connectives. How do we use these simple statements? We combine them using logical connectives. This table shows the 5 most important ones. You already know most of these from daily life. And first one is and is true only if both statements are true. It is raining and it is cold. Or it is true if it is true if at least one statement is true. Not simply flips the truth value. The most important one for AI reasoning is implies, which means if P then Q. This is our basic if then rule, and it's the foundation for logical deduction. Let's see propositional logic. Before that, we will see propositional logic components. In propositional logic, we can see propositions, logical connectivities, atomic and compound proposition, truth values, etc. Let's see with one example, propositional logic. Let's see this is in real world example. Imagine you are building a simple AI. We first define our proposition. P, it is raining. Q is I will get wet, and R is I will bring an umbrella. Then we give the AI a knowledge base with two rules. Rule 1, if it is raining then I will get wet. That is P implies Q. Rule 2, if I bring an umbrella then I will not get wet. R implies negation of Q. Okay, now we give AI the current situation. Fact 3. It is raining and I did not bring an umbrella. It is P and negation of R. Given all this, what can the AI deduce? It looks at fact 3. P is true and rule 1. If P then Q. From this, it makes the logical deduction. Q is true. I will get wet. This is a valid inference. Let's see with the truth table example. So, how does a computer knows those rules? It uses something called a truth table. This is just a simple chart that shows every single possible combination. For example, look at the AND table here. The only time P and Q results in true is when P is true and Q is true. A computer can use this table to mechanically check any logical statement and determine its truth value. It's simple but very reliable. Let's see the limitations of propositional logic. This seems great, but propositional logic has a massive weakness, which these slides illustrate. It's too simple. I can't understand the content of a statement. It can't talk about objects or relations. It lacks quantifiers, so I can't write a general rule like all humans are mortal. I would have to make a separate rule for every single human. If Sushant is a human, he is mortal. If Alice is a human, she is mortal. And so on for billions of people. It just doesn't scale. To handle complex real world knowledge, we need something far more expressive. Let's see with what is FOL. And that brings us to first order logic or FOL. This is the powerful upgrade. As the first diagram shows, FOL is a logical system that lets us talk about objects, specific things in the world like John or this book, properties, character, characteristics of those objects like I, like is read or is a student. Next is relations, the connection between objects like loves or is bigger than. To do this, as we seen on the next slide, FOL To do this, as we see on the next slide, FOL adds a few new building blocks. We still have constants which are specific objects, but now we also have variables like x or y that can stand for any object. And we have predicates which are statements about objects, properties or relations. This is the key difference. FOL mind map. Let's see. Let's make that concrete with an example. Look at sentence 1. John loves Mary. In FOL, we write this as loves John, comma Mary. Loves is the predicate, the relation, and John and Mary are the constant, the object. It's clean and structured, but the real power of FOL comes from combining variables with quantifiers. Look at sentence 2. All humans are mortal. In FOL, we write for all x, human x implies mortal x. Let's break that down. The, the for all symbol is the universal quantifier. It means for all or for every. X is our variable standing for any object. So this sentence reads for every object x, if x is a human, then x is mortal. With this one single line, we have captured a rule that applies to billions of people. This is something propositional logic could never do. Quantifiers in FOL. This slide goes a little deeper on those all-important quantifiers. As we just saw, they express if a statement applies to all or just some elements in a domain. There are two main types: universal, which means for all. We used this for all humans are mortal. Second is existential, which means there exists or at least one. For example, there exists X, cat X and black X, means there exists at least one X that is both a cat and is black. One fascinating that thing about FOL is that the order of quantifiers matters. For all X, there exists Y. Loves X and Y means for everyone loves someone. But if you flip them, There exists Y for all X loves XY. Means there exists one specific person who is loved by everyone. Completely different meanings. This expressive power is exactly that what complex AI systems need. Next, we will see the advantages of FOL. The advantages of FOL includes greater expressiveness, ability to represent general rules, formal and precise statements, foundation for AI, basis for logical systems, etc. and many. Let's see the disadvantages of FOL. But this power comes at a cost. FOL is not a perfect solution. It has three main disadvantages. First, it's more complex. As you can see, writing these formulas correctly takes much more knowledge and care than simple propositional logic. Second, it's computational expensive. Asking a computer to prove something in FOL can take a very long time. It's semi-decidable, which means it can find a yes answer, but it can't always find a no answer in a finite time. And third, it requires a proper domain. When you say everyone loves Alice, you have to define if everyone means everyone in this class or everyone on Earth. Without a clear domain, the statement is ambiguous. Let's see the main difference overview. This table is the perfect summary of everything we have discussed. I won't want I won't read every row, but let's hit the highlights. Basic unit. Propositional logic's unit is the proposition, a whole statement. FOL's unit is the predicate, a relation about objects. Quantifiers. Propositional logic has none. FOL uses for all, and there exist. Expressiveness. This is the key. Propositional logic Propositional logic is less expressive. FOL is more expressive and can describe general rules and relationships. Example The example says it all. Propositional logic P. For example, it is raining. FOL. For all X, human X implies mortal X. See the hierarchy. And just so you are aware, FOL isn't even the end of the line. As this hierarchy shows, there are even more expressive logics like second order and higher order logic, but they are vastly more complex. For, for most AI applications, FOL is the sweet spot. Let's see the use propositional logic and first order logic in artificial intelligence. So let's start with propositional logic. The advantages are expert systems and planning and problem solving. For FOL, uses are natural language processing and robotics. Let's see with a real world example. As you can see in the first picture, P indicates it is raining. Q is temperature less than 10 degrees Celsius. It is true. They are facts and the condition is if P and Q then S. 1. If raining and cold then heavy coat. 2. If not P and Q then T. Third, if raining Q not Q cold and long time out then light jacket. So what we have to do? P is true, Q is true. Is rule 1 applies. Therefore S is true. In FOL facts, fruit, apple, fruit, banana, cherry are fruits and red apple, red cherry, not red banana. Rule fruit X implies red X. If it's a fruit and it's red, then it's tasty. Query, is this apple tasty? Answer yes. Let's let's bring it all home with the summary. Propositional logic is simple, fast, and deals with basic true-false statements. Its weakness, it cannot express relationships or general rules. First order logic extends propositional logic. It gives us variable, predicates, and quantifiers. This allows it to present complex, real world knowledge and relationships like our all humans are mortal. And that brings us to our conclusion. There is a clear trade-off. Propositional logic is simple and efficient, making it great for basic reasoning tasks. But first-order logic, while more complex and computationally demanding, is far more powerful and expressive. It is essential for modeling and reasoning. What about the real-world situations and objects that modern AI aims to understand? So, thank you very much for listening me. Thank you very much.